Hello, this demonstration relates to enrolling new devices in Amazon Web Services. We are going to show two devices, a Nuvoton M2351 device based on an ARM Cortex-M23 microcontroller, and a Samsung Arctic 530 with an ARM V8 Cortex-A9 application processor. First, let's look at the default manual approach. I need to create each device in the Amazon Administration Console. It takes a couple of seconds. Then, in order to allow the device to connect, it has to be provisioned with a certificate. We either need to create a certificate and store it on the device, or generate a key externally and then use a certificate signing request to create a matching certificate. These approaches are fine for one or two test devices, but they do not scale. In this demo, we will explain how to automate the process from secure manufacture to cloud provisioning. The first step of the process happens during manufacture. We arrange that a private key is injected into each device so that the device can later prove that it is genuine. We can also inject one or more digital holograms that can attest the device has passed through specific additional stages, such as passing QA or outsourced manufacture. The unique device key and holograms are injected into an area of the device protected by ARM's Trustzone technology, preventing malware from accessing them. Trustonic has injected keys into well over 1 billion devices to date, and now we're extending this to the latest Cortex-M devices. When a device wishes to enroll with an AWS cloud, it can use this information to prove its legitimacy and to automate the process. First, it generates a certificate signing request. This is bundled with hologram information and signed in a secure partition. The message is sent to a service running in the OEM's own virtual private cloud and forwarded to Trustonic's cloud for validation. Here it is checked against a database of factory metadata, and details about the device's type and manufacturer returned to the OEM's cloud. Finally, the OEM can validate the device info and use Amazon's identity management APIs to issue a certificate and send it to the device. After which the device can make use of IoT services as a fully enrolled device with its own TLS certificate. These slides focus on a microcontroller device with ARM Trustzone M, such as a Nuvoton M2351, but the same principle applies to larger A-class devices such as the Samsung Arctic 530 running the Trustonic TE. Let's see it for real. First, let's show the Nuvoton M2351, one of the first boards with an ARM V8M M23 microprocessor. Let's plug it in and it will boot to show a Trustonic logo. When I hit the enroll button, it will go through the steps I just described and show an AWS logo when it completes. Now if I refresh the web console, you will see the device has been registered as type Trustonic thermometer. It also has a suitable certificate to enable it to communicate with the cloud. Now I can drill into the device and register with an MQTT event stream to demonstrate this. The device generates an event every few seconds of type Trustonic/temperature. And here you can see an event being produced by the device and sent securely to the OEM's cloud on AWS. Turning to the Samsung Arctic 530, this device has a larger A-class processor, the ARM Cortex-A9. It runs a full Trustonic TE, as do hundreds of millions of smartphones. This device has no screen, so we will monitor the log output to see it connect to AWS. It goes through exactly the same stages, generating a CSR, creating an attestation, and sending it to the web service for validation prior to generating MQTT events. In this video, we demonstrated the link from secure manufacture to enroll time attestation to automated provisioning in Amazon Web Services. For more information, please contact Trustonic. Thank you.